All right, so today we're diving into something that I think a lot of folks out there can relate to.
Okay, yeah.
This whole issue of data just being everywhere, right? Like, it's there, all this valuable stuff in emails, documents, chats, but it's like trying to find, a specific grain of sand on the beach.
Oh, I like that analogy, yeah.
Right. So how do we actually make sense of this sprawl of information? That's what we're going to dig into today.
And the paper that we're looking at takes a really interesting stab at solving this using something we talk about a lot.
Oh, yeah.
LLMs, these large language models.
Okay.
To build what they're calling an activity-centric knowledge graph. And this idea of like connecting all these dots of information, it's pretty powerful when you think about it.
So let's break this down a bit. When we say knowledge graph, what are we actually talking about?
You got it. So for those who maybe haven't bumped into this term before, imagine it like a map, right? All the important stuff in a company. Employees, the projects, documents. They're like points on this map. And then the connections between them, like who worked on what, who emailed who about a certain thing.
Yeah.
Those are the roads connecting those points.
Got it. So it's like a visual representation of how everything is related.
Exactly. And what this paper is suggesting is using LLMs to build this map automatically, taking all the data we generate every day and making sense of it.
Automatically. So we're not talking about like manually going in and drawing all those lines on the map ourselves.
No, not at all. That's what's so cool about this. It's a huge shift from how these knowledge graphs were traditionally built.
Yeah.
Which, was a very manual process. Like picture a bunch of experts, huddled over whiteboards.
Yeah.
Trying to define all the rules and categories of information up front, what they call an ontology.
So it sounds like very time consuming, very rigid.
It's extremely.
Yeah.
And companies change, their data changes. These old school systems struggle to keep up. The beauty of using LLMs here is it offers a way more flexible and scalable solution, potentially.
Okay, so if I'm following you, the big idea is that LLMs can look at all this raw data and figure out first, what are the key things, the who and the what, and then what are the connections between them, the how, without us needing to spell it all out beforehand.
You got it. The paper makes a really compelling case for why this matters too. They talk about these data silos and the problems they create.
Yeah.
Think about a research team trying to, build on past work.
Right.
But they can't find the reports they need. Or a sales team missing crucial info about a client.
Happens all the time.
Right. And it costs companies time, money, missed opportunities.
It's almost like a hidden tax on productivity.
Exactly. Like a tax we're all paying for not having this connected view of information.
Now, this framework they propose, it's not limited to just one kind of data, right? It's not just for emails or just for documents.
No, that's a key point. They designed it to be system agnostic, meaning it can connect with all sorts of different data sources using things like APIs and crawlers.
So basically ways to pull information from different systems, right? Like if you have your email in one place and your documents in another, it can talk to both.
Exactly. And it's built to be extended so you can plug in new types of data as needed.
Okay, that makes sense. But let's get down to brass tacks. How does this thing actually work?
Yeah, sure. So they lay out this 5-part architecture in the paper, figure 1, I think. It's a helpful visual.
Yeah, all right, let's walk through it.
All right, so step 1, the data ingestion layer. This is where the system gathers all that raw data.
Okay.
From your emails, calendars, documents, chats, all those sources using APIs and crawlers. But, and this is important, they put a big emphasis on security.
Got it.
And they're also really smart about what data they pull in. They prioritize grabbing summary level metadata rather than all the nitty-gritty details. That helps protect privacy, which is obviously a big concern for companies.
Makes sense. You don't want the system just sucking up every single piece of data without some kind of filter.
Exactly. So then, once the data is collected, it moves on to the extraction and summarizer part. This is where the LLMs really come into play.
Okay, so this is where the AI magic happens.
Right. First, there's the content extractor, which pulls out the relevant text.
Yeah.
And even visual info, if there is any.
Okay.
Then the real workhorse takes over, what they call the smart summarizer, which is powered by an LLM. But it's not just about making things shorter.
Right.
It's about condensing while keeping the important stuff, the entities, the activities, the relationships. They actually have a good example of this in figure 2 with an email.
So it's not just dumbing down the information, it's like intelligently extracting the key bits.
Yeah, exactly. And, another really important point, it's also designed to filter out sensitive personal information, which, again, from a practical standpoint, is huge.
Yeah, you can't have a system like this accidentally leaking confidential stuff.
No, not at all. Okay, so now we've got these smart summaries. What's next? Well, that's where the entity relationship extraction layer kicks in.
Okay.
This is where they figure out who's who and what's what and how they're all connected.
So okay, this email is from John Smith, who works at Acme Corp, and it's about Project X, that kind of thing.
Exactly. And they even use something really interesting here, this contextual retrieval module, or CRM. It's like giving the LLM access to a cheat sheet.
A cheat sheet? What do you mean?
Well, think of it this way. Imagine the LLM is like a really smart student, but they can't remember every single detail of everything they've ever learned.
Right.
The CRM is like giving them a super organized textbook, in this case, the existing knowledge graph. So when it's trying to figure out, say, who John Smith is, it can quickly look up any info it already has about him in the graph.
Ah, so it can use its existing knowledge to make better guesses about the new information it's seeing.
Exactly. That's what they call retrieval augmented generation, or RAG. And, academically, this is pretty cutting edge stuff.
Yeah. It's like the system is constantly learning and improving its understanding.
Exactly. Okay, so we've got our entities, our relationships all nicely identified. Where do we go from there? Well, that's where the real-time graph construction comes in.
Okay, so this is where they actually build the map, connect the dots.
Right. This module takes all that extracted info and starts building the knowledge graph, resolving any ambiguities, assigning unique IDs to everything.
So like making sure that every John Smith is the right John Smith, not some other guy with the same name.
Exactly. And it also has to make sure everything fits neatly into the ontology, the overall structure of the knowledge graph, whether that's a pre-existing ontology or one it creates on the fly.
Okay.
They use these things called embedding models, which is kind of like creating a numerical fingerprint for each entity and relationship.
Okay, that sounds complicated.
It is a bit, but think of it this way. Similar concepts will have similar fingerprints. So even if they're described using different words, the system can still see the connection.
So like if one document says marketing campaign and another says promotional effort, it can tell those are basically the same thing.
Exactly. And then they use LLMs again to map this new data onto the existing graph structure.
Okay, so it's a really intricate process, but it all comes together to create this connected view of information.
Right. And then finally, we reach the recommendations and analytics layer. This is where the rubber meets the road, where the knowledge graph actually starts delivering value to users.
Okay, this is where it gets practical.
Right. So they talk about several different applications in the paper. One is expertise discovery.
Okay.
Imagine you need to find someone in your company with a very specific skill set.
Right, and let's be honest, in a big organization, that can be like finding a needle in a haystack.
Exactly. But this system can do it instantly. It can tell you who has the most experience in, say, influencer marketing, or who's been involved in discussions about AI model optimization. It analyzes contributions, navigates the graph, and uses LLMs to rank experts by relevance. It's incredibly powerful.
That sounds incredibly useful. What other applications did they highlight?
Well, another big one is task prioritization. Because the knowledge graph is user-centric, it can actually recommend what tasks you should focus on. And it gives you the relevant context materials. And it's dynamic, so it adjusts as priorities change.
Oh, so it's not just a static to-do list. It's actually intelligent and adapts to what's going on.
Right. And then finally, there's insights and decision-making. Users can ask natural language questions. Things like, what percentage of tasks were completed on time last quarter? And the system translates that into queries on the knowledge graph. It can even segment the data by department, like in their example.
Wow, so it's like having a super-powered analyst at your fingertips.
Pretty much. And it's really cool. They didn't just talk about this theoretically. They actually did a pilot study. 6 months, 2 big companies, one in finance, one in healthcare.
Okay, so they really put this to the test in the real world. What kind of data did they use?
They pulled in emails, chats, project documents, and they focused on the expertise discovery and task prioritization workflows. They used all sorts of quantitative metrics to measure how well it worked.
And what were the results?
Really promising. I
Yeah.
mean, the numbers are all there in the paper tables 1, 2, and 3.
Yeah.
They got 92% accuracy for entity extraction, 89% for relationship extraction. That's pretty impressive. And they even found that the contextual enrichment we talked about earlier led to a 15% improvement in task alignment, meaning people were working on the right things more often.
That's huge. So it's not just about connecting data, it's about making sure people are actually using that data effectively.
Exactly. And, the user adoption rate was 78%, which is pretty high for a new system. And they met their objectives in 5 out of the 6 targeted scenarios. So overall, it seems like a pretty solid validation of their approach.
It definitely feels like a big step forward from the old static ways of doing knowledge graphs.
Yeah, absolutely. I think it's important to remember the historical context here. Before these powerful LLMs came along, building a knowledge graph was a huge undertaking.
Yeah.
You had to manually define so much stuff up front. And it was really hard to keep up with the way data was constantly changing. LLMs really have changed the game. They can understand and generate natural language, which is crucial for extracting meaning from all these different sources.
So what would you say are the most novel or innovative aspects of this particular work?
Well, a few things stand out. The fact that it's system agnostic is huge. It can work with whatever systems you already have, and you can easily add new ones.
Right.
And the user-centric design, that's another big win. It's all about making it easy for people to actually use this knowledge, asking natural language questions.
Yeah, that's a big difference from the old days of having to learn some complicated query language.
Exactly. And of course, the privacy focus, that's absolutely essential in today's world.
Okay, so we've talked a lot about the technical details, but what about the real world impact? How could this actually change the way people work?
Okay, imagine you're a consultant at a big firm.
Yeah.
You're working on multiple projects. You've got emails and documents scattered everywhere.
Right.
Now imagine, instead of spending hours, digging through all that stuff to prepare for a client meeting, the system just gives you everything you need instantly.
Like a personalized briefing book?
Yeah, exactly. And it can even tell you who the right people are to talk to, who has the most relevant expertise.
Wow.
And task prioritization. Imagine how much more efficient you could be if you knew exactly what to focus on at any given moment. It could really transform how we work, make us all so much more productive.
It really highlights the potential of AI to not just automate tasks, but to actually make us smarter and more effective.
Absolutely. Okay, so now for our novel notions segment, where we put on our futurist hats and think about where this research could lead.
All right, let's get speculative. What ideas are brewing?
Okay, so one thought that really intrigues me is this idea of dynamically evolving ontologies. Right now, the system relies on an ontology, whether it's predefined or created on the fly.
Right.
But what if the ontology itself could evolve, based on the patterns the system is seeing in the data and how users are interacting with it?
So it's not just building the knowledge graph, it's also constantly refining its understanding of what the graph even means.
Exactly. It's like the system is learning not just at the level of data, but at the level of concepts.
That's a pretty mind-blowing idea. What else?
Another thing that I think would be fascinating to explore is using this framework to proactively identify risks and opportunities.
Okay, how so?
Well, imagine the system is analyzing communication patterns, and it notices a sudden spike in, say, urgent emails about a particular project.
Okay.
That could be a sign that the project is in trouble. Or maybe it notices that certain teams are consistently hitting their deadlines while others are struggling.
Great.
That could point to opportunities for process improvement.
Right.
It could even identify emerging areas of expertise within the organization that maybe weren't even recognized before.
So it's not just about understanding what happened in the past, it's about predicting what might happen in the future.
Exactly. And, there's a whole body of research out there on anomaly detection, forecasting, all of which could be really relevant here.
That's a pretty exciting thought, moving from knowledge management to predictive knowledge management.
Exactly. It really opens up a lot of possibilities.
It really makes you think about the future of work and the role AI could play. It's not just about replacing humans, it's about augmenting our intelligence, helping us see things we wouldn't be able to see otherwise.
Absolutely. And, for anyone listening who's interested in diving deeper into this particular research, we'll include a link to the paper in the show notes.
Great. Well, this has been a fascinating deep dive. Really thought-provoking. Thanks for joining me today.
My pleasure. Always great to chat about this stuff.
And to everyone listening, thanks for tuning in. We'll see you next time for another deep dive into the world of machine learning.